Right. Good morning, everyone. Welcome to our second plenary session for the day. I think we've had a very good kickoff to starting of proceedings with our panel discussion earlier this morning. By now, you should know that you're actually sitting in the session for smart solutions for industry. So I think this is a very apt and fit topic for today. And before we get to that, let me just introduce myself. I am Kevin Cillier. I am the Technical Quality and Standards Manager for the Industrial Support Program at the CSIR within the Smart Places cluster. And I am also playing roles supporting both the National Cleanup Production Center, or NCPC, as most of you would have seen, and also we're also supporting and hosting in that industry support program the National Foundry Technology Network as well, as you would have heard this morning. So just a few things to perhaps go through, and in terms of what's going to happen and what we need to just be aware of. So just some housekeeping things. If I could just ask and remind people, please, could you ensure your phones are on silent? Don't turn them off. We are going to have opportunity where there may be interactions. I believe that later in our show there will be some QR codes or codes that will be put up, and you will be able to scan them, and there will be questions that will be shared with you to respond to and answer. It's feedback that will help us on your comments around what was presented and shared today, and that's really important for us to keep improving, and as we go year on year that we look at hosting this conference, we can ensure that we respond to the needs and the requirements of the audience. We will have 3 speakers today. They will go sequentially and present to us, and then we will have a session after that to allow for question and answers. And then just to remind us that we do have online audience as well that are joining us through Teams. So to those that are online, welcome, and we trust you will find it a very informative and fruitful session for today. With that, I think we can then look at proceeding with our program for the day. Yeah. Down for next. Okay. And I point it here. Okay, perfect. Thank you very much. Great. Okay, now that I've been lectured on how to go about it, we should be ready to roll. So just perhaps a few comments from my side in terms of today's session. As I've mentioned, it's the Smart Solutions for Industry session today. But I think what we've heard in this morning's plenary panel is that there is a lot of uncertainty, a lot of questions that both industry and government have, and we are required to try and gather and get information to be able to respond to this uncertainty and answer a number of questions or issues that perhaps we're not sure of. We've heard about the CBAM, we've got climate change bills coming in that are all making demands on us to respond in a certain way. But in order to do that, we need to know where we are, what the current status is, and that means we need information, we need data specifically. So today's session that we have is going to speak largely around the concept of data management, data collection, and we will even have a practical example of how we can respond and feed information back to industry in a data manner to provide them with answers or information that allows more informed decisions to be made. So we have our first speaker for today, and if I can ask the audio-visual room to pop up our slides, and I'll just see if we can get that. Thank you. I don't think that's the correct one. Okay, let's see, we'll try again. Could I get the data observatory platform using big data and carbon? That's Meryl Ford's presentation up, audio-visual room, please. Aha, okay, there we have it, thank you. All these little niggly things that jump in the way. So our first speaker for today is going to be Meryl Ford. She's going to speak on the data observatory platforms using big data for carbon and resource monitoring. And perhaps just a little bit about Meryl. Meryl is actually, she's a digital transformation specialist at the CSIR, so it's quite a big word, that. She's based at the CSIR Center for Robotics and Future Production, located in the manufacturing cluster within CSIR. She currently has a strong interest and is involved in the use of emerging technologies, such as distributed ledger technologies. Now, I'm not quite sure what that is, but I've got in brackets here, it's to do with blockchain. So many of us are familiar with that term. It also speaks to big data, as well as being in the robotics team. They're looking at the aspects and elements of incorporation of artificial intelligence. And then, of course, the big thing is the Internet of Things. And they're using all these platforms and technologies to actually support technical innovation in Africa. So if I could put Meryl on the spot. Meryl, could I invite you to come up and we can hear about big data and how we deal with it.
Okay, thanks very much, everyone. I don't know if we can have the first slide. Hello, up there? Okay, cool. So I'm going to be talking about data observatory platforms using big data for carbon and resource monitoring. It's something we've been working on for a while within our center. I just want to just reiterate that I'm a digital specialist. I'm not a carbon emissions specialist or a climate change specialist. So some of the topics are kind of a bit out of my comfort zone, but you'll see I'll start to perk up when I start talking about the technology. So this is just quickly what I'm going to be talking about. Going to be talking about data observatories around the world. How are data observatories in South Africa different? And then I'm going to, hopefully if I have enough time, I'm going to flick through a proof of concept that we developed with a small foundry in Johannesburg, and then some final remarks. So around data observatories, in case you're wondering what... Yes, so that I can see what I'm doing. Sorry, guys. Okay. Okay, it is switched on. Okay. Sorry about that, everyone. But now I feel like I'm ready to fly. So basically a data observatory is exactly the same concept as a physical observatory, except you're not pointing telescopes up at the sky. What you are doing is you are gathering data from all kinds of sources and big data sources, streaming data, etc., into a kind of a central data repository, or they often call data lakes. And once you've actually gathered all of that data, you use quite advanced techniques like AI and machine learning, big data analytics, etc., to actually start to make sense of the data. All kinds of interesting things become possible. And taking this kind of approach is critical if we want to really understand what is happening out there in the world. Looking at big data obviously is one of the kind of, I don't want to say new because it's not really new. It's one of the up-and-coming technologies that are kind of part of a suite of 4R technologies that are changing the world. It enables continuous and high-resolution tracking of carbon emissions and gathering the data and then analyzing the data. You start to make sense of, for example, the carbon footprint of industries, of cities and ecosystems. So it plays a crucial role in climate change mitigation. If you look at the kinds of data that it collects, it uses IoT devices, it uses smart meters, satellite imagery. So you start to collect data from different kinds of data points, and you combine them together to get a kind of a full picture of a particular situation. So if you look here, by the way, I do have QR codes up if you want to link to some of these sites that I'm going to be talking about. So for example, Google has developed something called its Environmental Insights Explorer. And it uses big data and machine learning to estimate carbon emissions for over 100 cities worldwide. The idea is to help cities plan for carbon reduction strategies. I did go and look and see whether Pretoria or Tshwane was on their system. Yes, they're on the system, but there's no data that's currently really being collected. So you can imagine Google can collect data from all kinds of sources. They can collect data from their navigation systems, all sorts of things. So the whole idea is to collect data from different sources to have a full view of what's happening out there when you do your analysis, or even to look at it from a particular viewpoint. So the benefits of data observatories, as I said, comprehensive monitoring. So you're monitoring 24/7. Things like emissions, you can monitor water sources, you can monitor all kinds of things. You can look at energy consumption, and once you actually start gathering the data, you can then start to have precise insights into carbon hotspots and trends. They're also quite critical in terms of regulatory compliance. I think this morning everyone heard a lot about what was needed. There's all kinds of new regulations that have come in to the country, maybe not so new, but so they help with compliance, both in terms of at a national level, but also at an international level. So if South Africa reports it has X number of carbon emissions, NASA's carbon monitoring system can actually check whether that's true or not. So yeah, very, very interesting. They can kind of double check everything we tell them. And then obviously improved decision making. So you can use, once you have the data and you've analyzed the data, you can get insights into what's happening. So you can use data-driven insights in terms of supporting policy, in terms of making informed decisions about carbon reduction, resource optimization. So this is the very impressive system that NASA has put together, and they do check, they check what people have reported versus their climate commitments under the Paris Agreement. Now, obviously, you know, if this is like so simple, then why isn't everyone doing it? Okay, it's not that simple ever. So there are challenges. The main challenges are, number one, it's complex and quite hard to do. Number two, it costs a lot of money. You'll see some of the examples that are provided. I've provided one from the EU. I've provided one from Google and NASA. Now, obviously, those guys have got big pockets. So, you know, it's maybe not as expensive for them. But as we see with all of these technologies popping up as part of the 4R, we can leverage technology to do things in ways that we could only dream about before. If you think about kind of 2 years ago, who would have thought you could have a conversation with an AI through a tool like ChatGPT? It was unthinkable. Yet today we take it for granted already. So there's new approaches to solving problems that we thought were unsolvable just a few years ago. There's a big focus on data as the new oil, and that oil is gushing. We are collecting data about everything at the moment, but I'm not sure that we're doing much with that data. And then, as I said, AI, machine learning, data analytics are making huge strides out there. They're part of our lives now. And there's huge opportunities to actually harness all of these new technologies to improve data accuracy, security, and integration. You can also start doing interesting things like forecasting and predictive analytics of carbon data, both at a kind of a company level, for example, at a city level, at a national level, and at a global level. And as I said, you know, it's scalable. You start small and grow is the idea. So let's talk a bit about data observatories in South Africa. You'll notice that when I spoke about the big national, international observatories out there, where money is not an issue, they're doing very sophisticated things. So I don't even want to guess how much data is busy flowing at the moment, but they're collecting real-time data all the time. You don't need to collect real-time data all the time. In South Africa, it's a much simpler problem. There's data scattered everywhere. It's sitting on researchers' laptops. It's sitting on servers down the corridor. It's sitting within a government department that maybe doesn't exist anymore. It's sitting in spreadsheets. It's sitting in paper forms. So we have a major problem in South Africa with all of these data silos. So a quick win and a big win is actually even just combining all of these data silos into kind of a single source of truth. That hasn't been done. This is my dream. But there's huge opportunities just in doing that. So I've included some examples of South African data observatories. These are from the CSIR. They're from our other centres within the CSIR and clusters in the CSIR. There's a South Africa Development Indicators dashboard that anyone can access. There's the QR code there. Have a look. It's very, very interesting. There's the Logistics Observatory, which is only kind of really kicked off this year, and already they are discovering all kinds of interesting things about the South African logistics system. And then you'll see on the right there, it's called the National Policy Data Observatory Dashboard, but you might recognize it. So during COVID, what we did is we actually created a major data lake / data observatory here at the CSR, and all of the data from multiple sources around the country were collected into that database. So all of the statistics that you saw on the news and on the web, that all came from that particular data observatory, and very, very successful as well. So if we look now, we're keen to look at the concept of a data observatory for greenhouse gas monitoring in South Africa. There's a lot happening there. I'm not going to go into details. Everyone is welcome to download this presentation. There are national reporting requirements. There is a national greenhouse gas inventory. However, there are major gaps in this inventory. Some of our largest emissions organizations and facilities like and sectors like the foundry sector, for example, doesn't have an inventory. If you don't have an inventory, how can you track what you're doing? There are quite a few voluntary initiatives happening. I know that a lot of the big companies and organizations like the mines and the energy sector are kind of doing stuff around green hydrogen, for example, because there needs to be a way of actually changing the current status quo. And then the carbon tax kicked in 2019. That was kind of initially it was a carrot and a bit of a stick until 2023. Now it's kind of a big stick and maybe a little bit of a carrot. So, legally, companies that emit greenhouse gases over a certain threshold have to report those greenhouse gas emissions. There are a lot of industry-specific efforts, and there has been an attempt through the SECO system to enable people to upload their greenhouse gas emissions on an annual basis. So the problems, the challenges in greenhouse gas monitoring. There's a distinct lack of industry-specific inventories in the country, especially the foundry sector. There's non-compliance amongst SMEs. This is a complex process. This is something SMEs aren't comfortable with. They don't have the skills. They don't have the funds to implement things. There's also the high cost of monitoring technologies. So continuous emissions monitoring systems, which continuously you set up the sensors in the system, let's say in a factory, and it continuously monitors what's happening on the factory floor in terms of emissions. I mean, we had a look at this. It was ridiculously expensive. We're talking millions of rands for one sensor. So, that's kind of really impossible to implement on a wide scale, even by the bigger organizations. If you look at the issue, as I've said before, limited skills and expertise, and then this lack of knowledge on proxy measurements. You don't have to put a continuous emission monitoring system in. You can use proxy emissions. So if you can measure how much electricity you're using, how much gas you're using, petrol, diesel, etc., there's something called emissions factors that will convert it into and help you actually report on those emissions in your environment. You don't have to use expensive equipment. And then inconsistent reporting and data quality. So we spoke this morning, they spoke about CBAM. So CBAM is a reality. I'm assuming everything was explained about CBAM. So, and the irritating thing is that the different implementations of CBAM are different. EU needs a different format report versus the UK, versus Dubai, versus the USA. it's a real headache. And some would say, well, that's an opportunity for consultants. But, why not make things a lot simpler and a lot cheaper? So there needs to be, we believe that there is a huge opportunity to create a greenhouse gas data observatory, initially focusing on foundries at the CSIR. So the reason, obviously, reason number one is CBAM. There needs to be a way to, and a tool for CBAM reporting. Opportunity number two, we know that the foundry sector is struggling at the moment. This can help them actually cut costs. If they actually are able to measure emissions on a continuous basis, they can start to understand how to be more efficient in their production processes. It will actually save them money if they start thinking in this way. And once you solve the problem in the foundry sector, which from what I've been told is quite a complex sector, it's a small sector that's under a lot of pressure, it becomes much easier to then expand into other manufacturing sectors as needed. And then the foundry sector has no trusted digital inventory. Can we actually create one for them as part of this greenhouse gas emissions monitoring process? So I know I'm running out of time, I'm going to flick through this. So we want to solve the problems that we are identified. So let's create the inventory. Let's support compliance among SMEs. Let's make it as easy as pressing a button and your report goes off. Let's make sure it's affordable. We live in South Africa. We have, there are challenges. We can't afford to pay millions of rand to actually go and monitor emissions. And often it happens once a year. So you pay a consultant quite a bit of money to come in. Over 8 hours, they actually monitor the emissions and you get a report. That does not mean that's an average of your emissions over the whole year. We need to de-skill the process, plug and play. There's this little box, you plug it in and your problem is solved. Use of proxy measurements, much simpler, much easier, much more affordable. And then consistent reporting and data quality. If your system actually formats according to what the particular CBAM authority needs, you don't need to worry about it. You can change the formatting a bit here and a bit there so that it conforms to what's needed out there. I'm going to just quickly talk about, we've actually developed a proof of concept, and this is a bit of what we did. So the idea was to do trusted and verifiable data capture and collection from foundries themselves. That goes into a data lake. You combine it with other data that's out there. You have a data management and analytics platform. We develop what we call knowledge products. And these could be any products. So you could develop a decision support product, a reporting product, predictive analytics. What can I, where do I stand now? And if I had to continue in this way into the future, where will I stand in a year's time? And what do I need to do to mitigate? So that's what we see as a greenhouse gas data observatory for the foundry sector. And we wanted to make it available to foundries themselves so that they can actually monitor and react. We want to expand to wider industry. We want to make it available to government. So once we've actually combined the data responsibly, so we're not going to actually show, it's going to be aggregated data. National trading partners, we need to do that for CBAM, and then national compliance bodies. So yeah, that's kind of what we did. The proof of concept, I'm going to flick through. We did a very successful proof of concept where we developed an emissions dashboard. We worked with a local foundry, McQuaid, and we really appreciate the support we got from them. We monitored for 3 months. I'm going to flick through all of that. These are a few pictures. We didn't do everything automated. We actually had forms. We just didn't have the time or the funds to do a fully automated system. These are some of the reports that are generated. And we developed a dummy CBAM report as well. I'm saying dummy because they don't actually export. And yeah, that's it. So basically, what I'm saying there is, there's an opportunity here. We can be more competitive. We need to start really thinking about new ways of doing things using new technologies that are emerging. So thanks very much, guys. She kept on holding up the thing and I don't have my glasses on.
Am I audible? Yes, no, maybe. Okay. Oh, that's better. As I said that this was a practical sort of application session and I think Meryl's given a great sense of kind of approach that could be taken around how to deal with data and how to compile it and consolidate it. And again, this is with the big question, and even in the National Cleaner Production Center environment, we're constantly being pressed for data. And I think you mentioned the comments around the challenges with getting data, and that I don't think it's only limited to the Greenhouse Gas Observatory. Those challenges and issues that were highlighted as to consistency of data availability, I think that's issues across the board in all formats of data that need to be collected. That moves us on, and I think now we want to see this in action and how can some of this be applied. And our next speaker is a duo collaboration. We've got Ms. Mbali Maro, and then we've got Davi Fourie. They'll be presenting and speaking to the best practices in data collection and management for monitoring, reporting, and finance applications. And just perhaps a little bit about those presenters before I call them up to stage, is that Mbali, as one of my close colleagues, she's a project manager within the Technical Quality and Standards portfolio within the NCPC, and her role is largely centered around the outputs and technical accuracy and quality assurance of the data and information that we do gather and collect through our industry engagement. She holds a master's degree in operations management and is also one of our local resource efficiency and cleaner production, or RECP, and energy management systems certified UNIDO experts. So we've got a lot of years of experience there. She's been in the game for 15 years. Involved in the manufacturing sector and focusing on process engineering and project management. Then just to introduce Davi, that we can make it streamlined. Davi is currently the managing director for Nero Solutions, I believe it is. And he's also an independent consultant involved in sustainability training and implementation support. He is also one of the NCPC's qualified trainers, which he is actually actively involved in a multiple number of disciplines which the NCPC offers and presents to industry and various other sectors. Okay, this is actually pretty useful in his ability to exploit his already acquired MBA and his manufacturing management and engineering qualifications. So this all provides a full package to industry and more specifically as well to the NCPC. He's also a qualified Six Sigma black belt, so it looks like we are in good hands with our two presenters. So if I could call up Mbali and Davi, if you would like to take your place.
Obi, if you can start with Davi's presentation, mine will come after his. I'll just wait for you later.
The thing is just at the corner and the down one is forward. Whichever one. I think it's this one. This one is forward. That's back here. Actually, so this one is should be forward. That's back.
Good day, ladies and gentlemen. My name is Davi Fourie, and I think Kevin did me justice here, overly. The main qualification that is speaking to what we're going to do here today is that I am a qualified certified energy management system, or CEM, as most of you call it, and a certified measurement and verification professional with the American Association of Energy Engineers. But we want to talk to data. We want to talk to data collection. And data collection is something that we know is not really simple. And I want to bring it down to grassroots levels. I want to bring it down to the mains and the basics of what we do when we do energy management systems implementation. And hopefully this can be learning for the foundry industry as well, because it's exactly the same thing. We don't do it differently at all. So in terms of, other way around, yeah. In terms of data collection and storage, the first thing that got my focus when I thought of presenting this was that we're living in an age, or the age of digital technologies these days. And as we know, in the olden days, when I bought my computer, I had 286 megabytes, and that was enough. But these days, we're talking loads and loads of data. We have around 218, and this was 2007, for in the digital space, around 280 exabytes of data floating around there. So data is everywhere. Right now, we're talking about cloud and cloud storage. This is where data really sits, and it's just increasing every day. It seems like in 2025, there's going to be around 16 zettabytes, and this is not billion, but trillion gigabytes of data out there. But what we do in a practical sense, and this is bringing it down to grassroots again, we taking information from different sources. Hendrik spoke this morning about Hulamin and how they have meters, and I can attest to that. They have more than 100 meters measuring different significant energy use equipment. So we're using meter data, we're using bills. For smaller companies, SMEs that don't have meters, so we use normal bills, and we can capture those bills in a format that could be well read and understood. What's very important in this case is we have to meter variables, and Meryl spoke about all these databases that's out there for measuring variables. Variables in this case, and simple ones, are variables to production, variables to temperature, and other user-defined variables. So what we use in variables mostly for smaller companies like retail, the spas, we use degree C, or heating degree days, or cooling degree days, and that is coming from a database called the NASA satellite database, and we're pulling information from there so that we can use in the analysis. That will then have to be collected manually or via loggers or even different softwares, and from there, obviously, it needs to be stored somewhere. And this is where this problem is coming in. We're storing so much data, and there's so much data out there that if we don't use it, we're actually wasting time. In terms of data and what we normally teach in at the NCPC or the National Cleaner Production Center, is that data has to be continuous, it has to be equal intervals, so that we can use this data to measure against variables, and we use the data in the variables and energy so that we can measure against each other and in synchronized format, put that into analysis, like regression analysis and so forth. We also doing, we should make sure that data is continuous. It should be correctly time-stamped. It also should not have extraneous values. Extraneous values, like for instance here, which seems like a monthly accumulated value, and also it should be free of estimates. And even in municipality bills these days, we know that there's a lot of estimations, but we want to use data that is quality and does not have estimates, so that we can make sure that that we do a good job when we do analysis. And analysis is most important because in the analysis, as Meryl has said, you can now define the process and you can learn about the process, and you can make decisions according to what you've seen, that you've analyzed in the data. So what we're doing, especially when we talk about energy and energy management, we want to make sure that we measure variation in consumption, variation in energy. As we know, it's always there. When we get a bill this year, or let's make it monthly, this month versus a bill next month, normal electricity bill, it will not have the same numbers in it. If it's the same numbers, then it's estimated. So it's always variable, and we want to know what is varying that. And there are certain things that does that. Efficiency, investment, static factors meaning that if my plant was running in 3 shifts and all of a sudden we're descaling and downscaling to 2 shifts, the energy would also drop. It would be a one-time drop, so it will not vary routinely, so we need to collect that information. We need to collect information of relevant variables, information that says that when I'm producing this much, this is the amount of energy that I'm using. Relevant variables can be all different things, and we'll speak about examples of that. We should collect renewable energy sources. For instance, if we now have a solar system all of a sudden and we want to compare performance versus last year, the performance will look like we're saving energy. Meanwhile, we're actually consuming from the solar system as well. So all these things needs to be correctly measured, correctly collected. There has to be a data collection plan that speaks to how to collect, who should give you the data, when should you be inputting it, what's the data frequency, and so forth. So that plan should be a developed mechanism that's used so that the data collection process should be perfect. In data collection, and what we want to do with the data is we want to see what it tells us about our consumption. And here, in this example, we can see that we have consumption of a certain variable, kilowatt hours, and here we can see each month there's a different value in terms of variable as well as in terms of kilowatt hours. So for instance, for this month, this data point is telling me that I've produced this many variables and I've consumed this much kilowatt hours. We want to do this because we want to understand what the plant is doing and how it's consuming kilowatt hours. Normally when you run a plant, and mostly practical experiences has taught us that there would always be a base load, meaning that even if we don't make one single piece of widget or production or whatever we're making, we will still have consumption, and that base load would always be there, and that base load is sometimes at 5%, and sometimes at 80%, depending on the process. And when you do this, obviously you want to make sure that you take that into consideration. So in the trend, we always try to not compare directly to only production units in terms of a specific energy consumption unit or kilowatt hours per production, because what that will be telling us is that in different cases, like for instance in this case here, where we are actually consuming higher than the average, we are actually doing good because we are lower than the kilowatt hour per production trend and so forth. So it shows us imprecise and inaccurate results. That is why we do regression analysis, so that we can get to the point of how much energy we're using per production unit, incorporating the base load into that. What we want to do basically with data collection is to view performance. So we create a baseline, which is that average best fit line between the points of my energy signature. And sometimes, obviously, you want to select a target, but where we want to get at is we actually want to measure how much did we consume this month versus the baseline, so that we can see if there is an improvement. Did we meet the target, yes or no? So these are the things that we do, but it starts with data collection. And sometimes data collection is a process that is frustrating, because we have to collect things like monthly energy from, let's say we're getting a bill from Treasury. Sometimes we have a normal electricity account, but also a green power electricity account, because the municipality in Port Elizabeth, each company is also, or most companies have got a green power consumption. So we have to analyze that. We create provisional bills, but sometimes you get a box of data like this here in printed format that you have to input into the system so that you can make the company understand what they're doing. So you should have a good system, energy management system, maybe aligned to ISO 9001, because we are inspection bodies. We use the system aligned to ISO 17020 or 1720, 17020, and these things here obviously is there so that we can use this data. And when you use the data, you do some analysis, and I'm not going to focus on this analysis because I'm going to speak to it later on. But the regression will tell you something, and you can then verify your consumption versus in this case here, it is heating degree days. You can do all sorts of analysis so that you can understand your data and you can make decisions based on your understanding. Same here. What's important here is we know ESCOM. We know ESCOM has got a wagon wheel. We know that energy costs are different in different times of the day if you are on a time of use tariff. So this is also important to analyze so that you can come up with things that make sense to you in terms of your data collection, in terms of all your energies in, where is it flowing to, and from these different plants, where is it going to in terms of significant energy use equipment. Okay, so these things are important, and this is just basically to show performance versus a baseline to see if we did well or if we didn't do well. So these are examples that I want to talk through, but first I'm just going to skip through this slide because this is what we all know. This is the process for energy management systems, ISO 50001, but what we want to get at from the data collection is that we need to come up with energy consumption trends. We need to set up energy baselines, energy performance indicators, specifically for significant energy use equipment so that we can get to understanding where we need to go to provide opportunities for improvement. Sometimes we look for variables. Variables is not easy to find. Sometimes we look for variables, and sometimes you'll find variables that associates with your energy consumption and sometimes not. And I see I'm almost out of time. Being practical, I'm going to skip to some of these slides. The software that I'm using in my day-to-day business is RedScreen, which talks about a cycle of data from collecting the data. Your location is linked to a weather pattern. You have facility information that you put in. You can put in energy, but I'm going to focus on data and performance analysis. Okay. What we see here is data collected over a period. And here we can see data collected. Here we have a data stream only for one of these meters, a data stream with around 74,000 lines or rows. And this data stream has got data for this 1 meter every 30 minutes. And we use this data to tell us a few things. We take that information, and like Meryl says, there are conversion factors. We then use the same information to make sure that we convert to tons of CO2 so that we can work out footprint as well from the information. Be it natural gas or electricity, you convert it into tons of CO2 equivalent emissions, and you also link it to a cost value. And once you have it in a cost value, this cost value will then afford you the opportunity to do performance analysis. Okay, so some examples. In this case here, as we can see, the performance within this year, 2023, was lower than the consumption in this year. And here we would think that now, if we set a baseline on 2023, we would think that 2024 was worse performance. But forgetting that we need to look deeper. And if you have data, you can do that. You look deeper, and what we found here in this period here, when you look at a period, you can see all these load shedding periods. So we had load shedding in 2023, before April or after April. There was no load shedding on this specific wastewater treatment plant system. So that means this needs to be filled up with whatever you're consuming. In this case was diesel because of generators, so the diesel consumption is not in there. We also look for variables when it comes to street lights. With street lights, you always have to look at nighttime hours. There's a URL that you can use to find daylight hours. You can convert it by 24 hours minus daylight would give you nighttime hours. And you can then use that to make sure that you provide a good analysis on daylight. And in this year, this lighting opportunity, we could then see a good improvement when we set times slightly different. And in April, we had constant energy usage. That's why it was a bad performance period, but mostly this is good. And with daylight hours, there's an 87% regression to the consumption of these streetlights, meaning they are controlled well. Things like normal variation. Sometimes you get normal variation. You don't need to do anything. We also get situations where we have more than one variable. We do multivariate regressions. We have more than one variable in this. If Hendrik was here, he would have seen that this is his information. Hendrik, sorry for using your information without asking. It's just an example. So in this example here, we can see that here we're using can body, can ends, tab stock, as well as other variable to find out what the real regression was around 97%. But here, all of a sudden, we saw a huge improvement, and this was incorrect. It looked like we saved, but when we looked deeper, we saw that it wasn't actually a saving. So that's why we have to analyze these things. When we looked deeper, we saw that for this green can body here, which was very low in this period, 2022 to 2023, October 2023, we just saw can body change. So there was a shift in the production of can body, and that caused the situation. But we then had to adjust by adding all the masses together versus total allocated energy, and we could actually see a 96% regression, and we could also see that we actually were not performing very good in that specific, for that specific machine. So these are the things that we're learning. I still have 1 minute. I'm still in time. Sometimes you think that you have saved a lot, but when you really do deep analysis, you find that for this CDC example, that these, for this company, in that period just before the saving, we could see a normal, a normal commercial consumption, and just after that, we could see reductions here during the day, which means that now they're using solar, and the solar is now kind of we're consuming from solar, so it's not really a performance improvement, but it's a solar system implementation. Yeah, so just to understand what these things are meaning when you do the analysis. Sometimes we find situations where we have, for instance, a compressor in this case here, and this compressor all of a sudden showed us very good results. But when we looked into these results, we could find that between there and there was a different compressor feeding information into this area, as well as between there and there, 10 and 14. 10 and 14, what that means was for 10 years, the compressor has failed, and we actually got air from C1 or a different building in this case. And that is why it seems like we were doing good, but we were not doing that well in terms of performance. So this is the type of things that we are doing to make sure that we understand and we use the data to make sense for our clients. And once we do that, obviously, then they can also take it over by themselves and make sense for themselves going forward. In this case here, data is very good when it comes to accuracy, if it's accurate, and the analysis would be good, and then it can be used for performance monitoring, carbon disclosure, or other types of finance applications. It's very important that data is collected. It must be correctly formatted. If the format is good, there's not much work to be done so that you can put it into analysis. Data analysis, you need to use the output in a manner that you understood. Too much data, data is never too much. For me, data is never too much. I love playing with data. So this is what we do in terms of data, collecting the data, and then using the data for purposes of improving plants. So thank you very much. Yeah. Now I can listen to you.
Okay.
Good afternoon, ladies and gentlemen. My name is Mbali Murwe. Davi and I are tag teaming on the data presentation. I'm going to be taking you through my presentation, focusing from an NCPC's perspective. Once Davi has been through the jungle of collecting data, then what do we do with the refined or the repurposed data that Davi and other consultants would have done? I'm going to skip through this because I think the NCPC has been introduced, but I'm here representing them, so the introduction has to be about the NCPC. I'm stressing this again, as Davi has stressed it as well, just because of who we are as the NCPC and the type of reporting or the type of data that we have. We still advocate for accurate data collection. Data collection is critically the first step in any sustainable consumption and production assessment. Therefore, it has to be done accurately because it has a cascading effect on the accuracy of the data and how you interpret it, as Davi has shown you, at company level, and how we will interpret it at stakeholder or government level. And critically so, this data will be the data that you will use for your environmental or economic assessment, and also just to monitor any consumption impact for your company. And we say if done correctly, it will definitely enhance your efficiency monitoring and also your reporting. So therefore, it's important that we do it correctly instantly. And ultimately, it will pave the way for integration of sustainability projects. I think this is the space that we find ourselves in as a country, and each company, unfortunately, right now, you cannot not have any sustainability projects within your company, but they require you to do data collection. So moving on, just on a few benefits of accurate data. Yes, it enhances reporting, and it also gives you some transparency on your operation. You know the type of data that goes into your company, the types of patterns that are there. Therefore, you'll have transparent operation reporting. It will definitely assist with compliance with any regulations, be it air emission regulations, be it tax regulations and so forth. You will need to comply with that, and you can only comply once you have data that is analyzable and that is accurate. Definitely what we advocate for as NCPC is operational efficiency. Never mind the type of resources that you have in the company. We advocate that with your data, you will definitely, once you've analyzed it, you'll identify any wastages, be it in material or be it in any other sources, be it energy, water, and so forth. And you'll also identify wastages and also inefficiencies, and then from there onwards, you can derive strategies to improve your operations and your significant material or waste or energy users. And definitely then from that, it will eventually lead you to calculating some cost savings now once you've implemented any optimization strategies within your company. And from an NCPC's perspective as well, it will ensure that it improves efficient stakeholder engagements. You know, when we stand in platforms or have collaboration projects with other stakeholders, once we have solid, accurate data that we can provide or that we can collaborate with, we will make sure that those projects are successful. But within a company's perspective as well, you will be building trust with different companies that we as NCPC work with. You know, we are using accurate data, and also when we do maybe at industry-wide studies or sectoral studies, once we know that we're using accurate data, we will definitely gain trust from those stakeholders. And of course, this is also fundamental, reporting on sustainability initiatives within our space or within our country or provinces, and also just track the progress of that. So Davi has touched on this, but I just want to emphasize on it. At this point in time, we will forever be using these three methodologies of collecting data right now. We would do the paperwork, the box of paperwork, sieve through it, and then input it into any data system that we have, be it Excel or any online software, but definitely we are still using these three. And yes, as NCPC, we will forever be encouraging companies to move to the smart metering because it's accurate, it gives real-time data, but we also understand the cost implication of it. Therefore, we'll still do the generic surveys and manual audits that we do. It is a tedious process, but it's worth it if we do it instantly and we do it correctly the first time. We also advocate for industries or organizations to do self-reporting, which is also important. Then we can tap into that data and use it as well. I'm sure from the case studies that we've shared in this conference and also the promotional material that has gone out from NCPC, just hyping up this conference, you've seen some of the figures that are displayed on the screen. These figures, we use it from the data that we would have gathered. and we make sure that we only use data that we know it's accurate and it's been collected properly. So our savings calculations that are displayed here, this is the energy one, water and waste, and then eventually the carbon emissions there. We use all the data gathered from companies to calculate what is the impact of NCPC. This data is only on companies that NCPC have assessed, have walked the journey of implementation, monitored the progress on the projects that we would have started, and then eventually have done case studies on seeing how our journey of efficiency has taken us. So that is how we get to these figures. I generally get a lot of questions when people come through our work to say, how did you get to these numbers? So now I just wanted to clarify that we ensure that we get it from the work that we have done, and we only use accurate data that we trust in order to calculate these figures. And of course, we have to also supply our data to government department as well. The first one, it has to be the DTIC, who is our funder. And definitely, we believe that our data contributes in the green industry policy and other related efforts, of ensuring that we promote economic ventures in South Africa that have a lower environmental impact. But also we believe that we need to also continue to promote the development of circular economy, and that we believe that data sources or data supplied is important, and it's an anchor of circular economy as well. And we believe also that our data and our work that we submit to the DTIC supports in the formulation of incentive grants, and definitely we believe it also have an impact in any international trade negotiations that happens at DTIC level. We also partner with Department of Science and Technology, just for us being here at the CSIR, CSIR being funded by the Department of Science and Technology. So our data also contributes to their feasibility studies that they do, some research work that they do that promotes green technologies, and also right now the big one being the green hydrogen project. If I move on, definitely we cannot not work or collaborate with the Department of Forestry, Fisheries and Environment as the custodian of tracking our national emissions. So our data also goes to them. I'm just highlighting these government departments just to see the importance of gathering data. It does not end only at NCPC, but it goes further, and actually it impacts our national reporting and submissions as well. So Department of Fisheries, we also submit data to them based on the work that we have done in different industries, and that impacts the country's reports that is submitted. We also do some interactions with Department of Minerals, Resource and Energy. In the data, from our data, it contributes when they are doing benchmarks and baseline studies, and also right now we will contribute as well in the review of the National Energy Efficiency Strategy. We will continue to work with them and submit all the relevant data sets that will impact the review of this strategy. And really, I added this slide just to highlight these four pillars of the impact of our sustainability that we collect as NCPC. Definitely in policy recommendations, there is no other way that we can supply data and it doesn't influence policy, specifically policies around the sustainability space. There are different of them. It can be tax incentives or tax regulations. It can be carbon pricing, water management, and so forth. Our data plays a big role in that. There's also customized solutions that we develop with our collaborative partners. We've got one that is currently running right now with the Danish government that is more water focused. We developed, in conjunction with our partners, a water balance, and then we've recruited companies that we work with where this is actually piloted, where real-time data is collected, and then futurely we would like to see how the water balances will actually work in those companies. Definitely benchmarking. I think it's important, especially in benchmarking and baselines, that we start to use real-time or accurate data and move away from estimates so that it can really give a real, true meaning into that particular industry. So we have started to do a few. We have identified the data gaps in that, and we will try to ensure that we close them. We will not close them now. It's still a long journey just because of the differences in the economic space of our country, and also just that the software or the tools of gathering data, they are not free, they have a price tag attached to it. And also you are going into a company space wanting data that is a bit private according to them, so we also need to gain trust. You need to ensure that you formulate working relationships before you move to that. As Meryl said as well, that maybe you can use proxies, but if you don't have basic data as energy consumption, then the proxies as well are almost invalid or unusable. So it's important that we gather that relationship with companies and that we move forward in developing meaningful baselines that are relating to the South African's perspective. And then yes, for us, resource savings, yes, we would like to show off and say this is how much we've saved, but we can only do that once we have accurate data that is collected. My ideal world, I'm advocating that we have some sort of a data management system. I think if I dream big, I'll side with Meryl, have a data observatory. But I think if we can just start small, have a data platform where we can plug in all our initiatives and plug in all the data that we collect and be able to track it and monitor it and develop trends. And also make sure that the data is adaptable and flexible to be used by other stakeholders as well in their different research or in their different feasibility studies or benchmark studies. And also maybe streamlined data analysis tools, as Davi has shown you the different graphs and the different trends that he has done. Thanks to Hulamin, Hendrik, I think you should be co-author of our presentations as well. It's for companies like that that open up for us and share this data and give us an opportunity to analyze and pinpoint trends or important information that we need to take note of when we move to other companies. And it will be ideal that we are able to integrate our data collection or our data management system with other departments' data management system, just to make sure that we stop sending each other spreadsheets and that everyone can access the data when they need it, but for an appropriate use. And also when it comes to policy recommendations or review of any sustainability reporting or review of any incentive, that it's done with accurate real life or recent data. You know, it's one thing that we submit the data, but it needs to be accurate and it also needs to be as recent as possible so that it depicts the current situation that we are in. The next steps for us as NCPC, it goes without saying that we need to increase our collaborative efforts within our stakeholders and institutions. That is fundamental because there's different institutions or different organizations, but working in the same space. And I think it will be ideal if we learn to share information amongst each other, then going back individually to industry associations or to sectors, asking for more or less the same information. And ideally also we need to carry on collectively working on standardizing the data collection methods and platforms. That will make sure that it's easy for us to analyze and it's easy for us to also interpret. And importantly as well is that the data collected, it must be managed in a way that's really flexible, you know, and accessible for any other reporting. And I think my last one, I was in and out of putting it here, but I think we need to continue to invest in initiatives that will improve the data collection process, the storage, and also the analysis initiatives. Just bearing in mind that the industries that we are working with are different and the financial implications of it. And also just to make sure that everyone is actually involved or included when we do the different analysis. And I just highlighted these four strong partners that we still need to continue to work with, because we are working in the same space, we are using the same data, we are producing similar work as well, and in most instances, we are collaborating with the same company. So it's important that we strengthen and we ensure that we carry on partnering and doing collaborative work. Also to avoid repetition, one can focus on this particular sector, the next can focus on that, but we are able to share the information so that we increase the impact as well. So these are our key partners and our key stakeholders that will forever carry on engaging in it. CSIR being there, because CSIR as well has a bigger arm, if I can use that word, because it has different institutions also internally, but also working around climate change, sustainability projects. So it's imperative that we still foster and carry on collaborative and information sharing sessions amongst these organizations. My presentation was really going to be short because Davi was going to cover most of it, but ultimately it was just to highlight that data is important, it is relevant, we just need to all pull together and collaborate in ensuring that we have one data management system that we can all leverage on and ensure that we come up with a solution to ensure that we move forward in the efficiency space. That is all from me. Hopefully I've answered all the questions that I generally get at NCPC. What do we do with the data that we submit to you? So I've just highlighted through the processes or the different segments of data and how we actually submit it to different stakeholders. But we will continue the engagement with different spheres. Thank you, Meryl, for joining us. Yes, the ideal goal is the data observatory, but I think we need to start small and just ensure that at company level, let companies understand why do we need to collect data and why do we need to interpret it and how they can benefit before escalating to us at NCPC level. Thank you, ladies and gentlemen, for listening to me. Thank you. That's all from my side.
Right, thank you, Mbali and Davi. I think that's given us a good insight, and I kind of like the way the presentations have flowed. We've had Meryl starting off gave us an indication of how one could deal with and consolidate the data in the lakes and various other mechanisms. Mbali and Davi have given an insight as to getting into a company and how to extract that data and what can be done with it. And now our final presentation for today is going to be from Vinesh Miraj, and he's going to share with us something around the digitization of the corporate sustainability reporting directive requirements for environmental reporting and an case study that they've done for ArcelorMittal. And I think that pulls it nicely together because we've seen the progression of what you can do with data, and I think this now will show how you can spit that information and data out in a consolidated form in a meaningful report for industry. So Vinesh, if I can ask if you would come up while I introduce you. So, as I indicated, Vinesh will be speaking to the digitization of corporate sustainability reporting initiative they undertook. Vinesh is the director in the Operations Transformation Department at PricewaterhouseCoopers, South Africa. He's been working with clients in the energy, utilities, resource and industry manufacturing areas since 1995, so he's probably a little bit like me. We've got a CapEx number on our head. And he's also been the leader of the smart manufacturing practice. And in addition to that, He's currently also a registered professional engineer. His key focus and interest and emphasis at the moment is around digital strategy formulation, manufacturing information management systems, incorporating 4RR technology roadmaps development, and as well as industrial automation and control. So you can see all of this links in very strongly with the collection and consolidation and gathering of data, and what do you do with it now. So I'm going to hand over to Vinesh, and he can inform us of what they've done. Thanks, Vinesh.
Good afternoon, everyone. Okay, sound check. I don't think you can hear me. Can you hear me now? Yes. Perfect. Thank you so much, Kevin, for that kind introduction. So I have the unenviable task of being between you guys and your lunch. So I will try and keep this to the 20 minutes and tell you about an 8-month project in 20 minutes. So please bear with me as I go through this. So I'll be talking to you about 3 things. So introducing the companies involved, then telling you what CSRD is all about in a few slides, and thereafter taking you through an overview of the project. So as you heard, I can't mention the client because I am an engineer and not an auditor, and we have certain corporate compliance requirements. So you know who the client is, but I will not put the client's name on the slides. But you can see they're the largest steel manufacturer in Southern Africa, and they serve 27 countries, and they have over 10,000 people. We are working with all of their operations in South Africa, as well as their head office in Europe. And we as PwC, as you probably know, we are auditors and accountants, but we actually have a consulting division, which is not very well known, so I'm here to represent them. And I am an engineer, as you heard, so we're not all accountants. And our role in the smart manufacturing business and the consulting part is to solve the important problems of our clients and create sustained outcomes. And this CSRD reporting was a very, very important compliance problem to solve. So, what is CSRD? So, if you are not European headquartered, you probably haven't heard about this. So it's a corporate sustainability reporting directive. It's part of the EU Green Deal to ensure that Europe becomes completely carbon neutral by 2050. And it has various criteria. So who is over 50,000 companies? As you can see the criteria there, and it's the EU entities. If you meet any of those 2 criteria, be it the 25 million euros in assets, or the 650 million euros in turnover, or the 250 employees in the European Union, you have to then comply with this. If you're non-European, you don't get away with it. One of our pharmaceutical clients has got operations in Europe, significant operations, and they have to comply with this regulation, I would call it, because it's a directive. So and that's what creates the urgency for our client. The first reports have to be in by January 2025. Similar to how CBAM has to be in by 2026 when you actually have to start buying CBAM certificates. So there's a lot of pressure coming from Europe in very short spaces of time. And the why is, I think we all understand that, right? We are seeing more and more climate change. We in South Africa are experiencing that quite drastically, particularly in KZN and the Western Cape and the Eastern Cape, and we need to all understand our responsibility towards having a more sustainable economy. So it has to be in the benefit of the 3 Ps, people, planet, as well as profits. So from a timeline perspective, 2025 first year, but then thereafter larger entities become liable in 2026, and you can see the other timelines going all the way to 2029. So there's a bit more detail about what CSRD is all about. It covers your basic ESG, which is becoming in vogue now, and it has 2 main standards, the ESRS1 and ESRS2, and they have different purposes, but I'll just focus on the 3 main areas. And as you heard in the introduction, we're speaking more about the environmental aspects here. So it's all encompassing, looking at environmental, social governance, and you can see because of the social, you're talking about everything in your value stream. The workforce, people in your value chain, your communities around you to maintain your social license to operate, as well as your consumers and end users. And this becomes important when you start looking at what you call the Scope 3 emissions. So under environmental, which was the focus of this project, we had to look at the impact of climate change under E1, pollution, which is obvious for most manufacturing industries, water and marine resources, biodiversity and ecosystems, which wasn't as relevant here, and resource and circular economy, which I think we need to encourage more about in South Africa. So an overview of the project that we did to help the client report on these parameters, the E1 to E5. The client standardized on Microsoft Sustainability Manager globally, and they needed to meet the January 2025 deadline. They're a bit slow out of the blocks, and they engaged us in March this year to get the project done. We mobilized with our global team who are helping other ArcelorMittal entities to comply. The local project included the automation of all the Excel-based systems, and yes, you're not alone. Everybody has got this MES, Microsoft Excel system, and it's one Excel that leads to another Excel that leads to another Excel. And the financial people give you an Excel sheet, which is then used by the environmental people. And we had nested Excel sheets to deal with here. And PwC was selected by ArcelorMittal as the global partner to implement the MSM system. We needed to map all the data to automate the process from source to target, and I'll spend a lot of time describing that to you, which is what you want in Bali. So there's a summary of the project before I get into the details thereof. So if you look at the challenges there, they wanted to standardize and streamline the current processes of manual data collection, which I'm sure most of you are struggling with in this room. They needed to enable significant improvement in the traceability of the environmental data, understanding that this is a directive, it's compliance, you have to have full audit trail, etc., etc. And they wanted to have a common platform for users to query the data and all of the different parameters, and even forecast how they would be attaining the net zero and other goals. And I'm sure that's what you want in Bali. So the benefits derived was, a single source of truth. This is that whole holy grail that we all are trying to strive to, get one source of data, not have multiple systems where you're exporting to CSV files and then collating to another Excel spreadsheet. Accurate reporting, because we know where there's manual entry, there's potential finger problems, and as you saw there, that large monthly data that you have to pick up, so somebody has to do some data quality analysis. The traceability of the data, that's why we want to do away with spreadsheets and go to the actual source of the data. Planning and monitoring to enable you to see how you're going to achieve your goal, and tracking your progress, because most clients we have conversations with have got net zero commitments, either 2030, 2035, 2050, but you ask them how much they've reduced the carbon, and if they're on track to achieve that, it's difficult to get the answer. And they wanted wide coverage because obviously this client has got operations across the entire world. I won't go through all the details. I'll talk through that in the next few slides about how we actually went solving this problem. So the conceptual data architecture is what we call data as a service. Now this is also, we've applied this principle to the mining industry, and the mining industry has adopted this, and there's a pilot project being rolled out as well. So you can see data is just data. It can be applied everywhere. But what this talks about is source to target mapping. So you normally have all your sources on the left-hand side here, and you can see there's different types of sources. It can be a database, it can be another system via API, it can be an IoT data source, it can even be an Excel spreadsheet. And then you ingest that data, then you land it, and then you transform it, then you structure it, you create insights from it, and then you present it to the user, and you try and automate as much of that process as possible. So in this, you can see there's a semantic layer, which is giving you all the additional information around the data, but you also need some data science around it to extract the deep insights. So you can see the 3 types of data, which is structured data, which normally comes from most of your transactional type systems. You have your unstructured data, which will be pictures, voice notes, etc., which people don't normally collect, which is now becoming important. And then your streaming data, which is normally from your IoT sensors, etc. And in this instance, the client had decided to go to IoT sensors because they had a large number of water meters that were sitting out in the sticks that needed to be collected, and you don't have a reliable power supply there. They have to be battery operated. If you do put solar panels, they're going to be vandalized and the battery stolen. We know South African challenges we have. So you have to be very creative in how you collect this data from very, very remote locations. So the as-is architecture of the client was as follows. You had 3 main source systems, the SAP ERP system, because that's where most of the financial data stood, how much you paid for all these different environmental things you bought. And then you had an environmental system where they collated all the information from their various control systems. So they have their control system running all the operations, and that had all these continuous emission monitoring systems that cost millions of rands coming into it, and then that aggregated data and fed it into this environmental monitoring system. And then, as I mentioned earlier, tons and tons of Excel files with multiple workbooks, worksheets in a workbook that link to other workbooks. So, sorry, let me go back there. So basically, that data was fed into a data lake. The client had already adopted Microsoft, as you would have expected. They had a lakehouse, and they had the typical medallion architecture, which is a bronze, silver, and gold, if that means anything to you if you understand this architecture. And the challenge with this was that it was an uncontrolled environment. So instead of being a nice data warehouse or data lake, it actually became a data swamp because everybody put in stuff there. And the good principles of data as a service is you land the data once and you use it multiple times. So you don't have duplication, and that makes your processes more efficient. So they asked us also as part of the project to ensure that we start helping clean up what was going on in there because it was an uncontrolled environment. And then you use all the Microsoft tools like Synapse, etc., to analyze the data. And then they had the Synapse serverless SQL pool. Serverless meaning it does not store the data, it just processes the data. So there's some business intelligence concepts. So we have to measure the CO2, right? But you just talk about all the complexity that our colleagues before spoke about. It's very simple to say I got X tons of CO2, but the question is, when did you measure this actual variable? So that needs to be tagged to the actual value. The next question is, where was the CO2 produced? Which site? Which machine? Etc. etc. So you have another parameter you need to consider there. And then finally, in what category does this data fit? Because you need to categorize your data under E1 to E5 for reporting purposes. So that's where we had to now contextualize all of this data for the client within their environment. So this is a typical conceptual data model that we built. This is the client's spreadsheet. With their permission, we're showing it to yourselves. And here, what we're doing is mapping relationships because now we want to get insights out of the data. So wherever you see an X here, it's where there's a relationship between the horizontal row and the vertical column. So you can draw insights like where your oxygen came from, etc., etc. Using that, we then created the logical data model, which now shows you the relationships between all your different data sets. So you can see there's multiple tables here. Some of them are sitting in the ERP, some of them are Excel spreadsheets, which is typical things like sales data, procurement data, consumption data, all mixed up, and we had to now make sense of that. So standard in Microsoft Sustainability Manager, they've already configured the water, waste, and CO2 data models, but we had to create the air data model as part of the evolution. We are working very closely with Microsoft in evolving the Microsoft Sustainability Manager so that it keeps getting more and more functionality. So if you look at the data flow in what happened here, just a couple of examples. You look at the complexity involved to get to a high level of maturity. You've got your data sources, which is once again the source to target mapping type philosophy I was talking about earlier. You're at SAP as one source where you have a start. You collect all your scope 1 information from your scope 1 files. You've got your scope 2 files. Then you've got your other data source files. And then you've got everything else in between. And you can see different people's names, who these files belong to, etc., etc. And then eventually you get to the actual consolidated information, which is in a report. A similar one for the data flow for each of the, for the waste flow. Here you can see it was not as well automated. There's no ERP information in here. We're collecting information here from weighbridges and other things, and some of it is just purely manual data ingestion, which then creates challenges when you want to now use this for compliance, because now you need some assurance on the data from an auditor, because the organization will need the CSRD organization will require you to validate what you're presenting to them. As you can see, everything had to be mapped out in a fair amount of detail. So what we came up with as a final to-be architecture for them was, you've got your 3 primary data sources, as you can see there in the top left-hand corner. Then you've got your shop floor systems, which is those water meters we spoke about, plus the client wanted to use the IoT, which is in this case, we recommended a LoRa WAN, long-range WAN, wireless radio, actually up to 120 kilometers, to collect information from those very far-flung water meters and other devices. And then that would be brought into a IoT streaming layer to be ingested into the overall data lake, or we're calling it a lake house, because it's a combination between a data lake and a data warehouse. And then that's where you see a normal medallion architecture, very similar to the beginning, but what you see the difference here is there is a corporate Microsoft sustainability instance, and then there's a virtual local MSM instance for the local organization to use and get their insights from. And there's data validation across the entire area, so this whole solution will be audited by the client's external auditors next year in February to show that the data is valid, is being handled thoroughly, correctly, and then presented correctly as well. What you see at the top right-hand corner here is the self-service reporting. Because you have now this lakehouse with all this wonderful data, you can draw whatever information you want based on relationships of the data in the database. So you can bring up whatever insights you want between water, air, oxygen, or any other pollutant, etc. And the other part was the IoT piece. And those 2 pieces are going to be done in a different phase, because the priority was to get the initial CSRD part up and running. So the timeline for this project was 6 weeks to do the analysis and come up with the design. And then we have 6 months to implement that. And that's where we are halfway through this project in September. The deadline is for November to get everything done and reported on, so we can test it, so that the 1st of January, before everybody goes on holiday, and the 15th of December, this is all up and running, and they can then be confident with their reporting when they get audited in February. And with that, I've managed to keep within my time limit. So thank you very much.
Awesome. Thank you very much, Vinesh. Yeah, I'm in awe. We're really jealous about that, because I think that's something we were also very closely eyeing. So hopefully we can get to that point. Ladies and gents, that concludes the presentations for today, but I know we're running a little bit late. I think lunch has been pushed to 1:45 now, so we're not too bad on that. And we did start a few minutes late on the session. But I would like to maybe give an opportunity if there's any questions that need to be asked. Yeah, I see a hand up on the top there. Yeah.
Hi, my name is Karine Jafta. I just wanted to, with the 2 first slides, how does the use of solar and getting off the grid in long term affects our economy and the GDP. If we look at the sustainability and also scaling with data analysis. And then also the recycling, the data for recycling of solar panels, stats and data regarding that, and how impact in analysis can also be part of the analytics to steer us in the right direction if we look at different levels of impact, either within the economy or within the environment. Thank you.
Thank you. Just to confirm, did you have anybody particular in mind that you were posing the question to?
The gentleman with the energy usage. Sorry, I don't get his name.
Would it be Darby in that?
Yes, that's it, yeah.
You can use that. Thanks.
Thank you for the question. In terms of solar, when it comes to solar, the way we do when we do energy analysis, we always make sure that we include solar as a different energy stream, making sure that we don't see solar as or the impact of solar as better performance in the performance period rather than the baseline period. But in terms of the environmental impact of solar, I would not be 100% clear on what that would mean, Kevin. So maybe rephrase your question.
Yeah, when you look at recycling of solar panels, currently in South Africa, we don't have proper recycling systems in place to do so. So what is going to happen in the next 10, 20 years or 50 years when it comes to the impact on the environment?
Very good question, and it will be an impact, because I can also already see, working with municipalities, that municipalities in Europe, after using their solar systems after 20 years, they're actually posting it to municipalities in Africa. So that is called dumping, and that should not happen. From a point of view of South Africa, I don't think we do allow dumping. But in terms of making sure that solar systems has a way forward in terms of landfill and getting it to the correct way of sustainably managing its end of life, I'm sure the programs are being set up for it now. I cannot say that I know the processes or the programs, but it's something that we should all research on. I wouldn't have an answer for that.
Thanks, Darby. I'm just checking. I've seen a couple of hands there. Okay, Inga, do you want to go first? Or?
Thanks, Kevin. I'm Inga Makotla, Project Manager for the NCPC. My question, I think, is also directed to Davi's presentation, just around the type of meters that we can use to feed the information to the red screen platform. Does it need to be online metering that can feed such information? I suppose the aim was to take out the manual feed of information to that red screen. So what type of meters, I suppose then maybe Hendrik as well can respond to that. Maybe they're using a Schneider product or anything like that to feed such information. Then my last question, I suppose, might be directed to Mbali as far as the period of the data that we need in developing the baseline. How far back can we go? I know some companies might have started with collecting data as far as 5-6 years ago, and they've suddenly stopped collecting that data. And now all of a sudden they realize that they do need to collect data for starters. Then in developing a regression analysis that was made mention of. So how far back can we go in submitting this data? Is a 5-year period still fine? or should we move forward in terms of developing a baseline? What data or what period would you accept in developing that baseline? Thank you.
Cool. Can I take your question, then the panelists can give it some thought while we tackle the first one, but do you want to...
Yeah. Thank you very much. Lester Moroba, I represent ZA Space, which coordinates the South Africa space industry, including BRICS and some other portfolios within the DTIC, including science and innovation on science diplomacy. There's a concept of a hyperscaler infrastructure that can be built at Guha, the special economic zone. And Meryl, I think your data observatory is something that fits in very well over there, so I'd definitely like to link you up with some of the proponents within the investment office there, so that we can get this built within the next 2 years. At scale, for South Africa, public and private sector, and to a minimum of another 17 African countries. I'd also like to find out how do we link this data observatory across all the centers of excellence as well as all the national key points? Because fundamentally, that is a key resource that we should be leveraging as a baseline to create a backbone for the rest of industry. And I don't see that happening at the moment. The third question I've got is on the solar side, specifically on residential, there is a lot of excess power production there that is absolutely going to waste. Are there any solutions we can look at over there to make sure that we leverage the infrastructure as invested by the citizens? Thank you.
Thank you. Okay.
So if I can manage Inga's question.
Yeah.
Inga, thank you for the question. In terms of data flow into Red Screen, there's a few ways in which you can get it in there. So CSV file, you set it up as an upload table, and you can press a button and it will upload every month. So that's the one way, and that's also the way I manage Hulaman's data. It's from a CSV file that I pull into the system. But there are links, SQL links, that you can use to program a meter so that you can move information directly. In terms of already set up meters, there are certain types of meters that's already set up that you can use green button. There's a green button that you can press and it will pull information from meters like that, like the hydro and so forth. But that's more European. For South Africa, right now we're using APL source into SQL, and from SQL directly into Red Screen. Okay.
Thanks, David. Bali, do you want to take the data one on the period?
Thank you, Iga, for your question. We generally say we require minimum 12 months of data, but ideally 36 months is much better because of the many different data points that you would have had. But I wouldn't necessarily, Inga, put a year of saying as far back as 5 years or so, but I would say as long as the data is accurate, it has no gaps, there are no estimation, and it's actually the true reflection of what is currently happening in that process, then the data can be easily used for formulating a baseline. Even when you reach the stage of formulating a baseline, you need to go through the few points that I've said. Is the data accurate? Are there no gaps? Are there no estimation? What is currently happening in the operation? Because you need to take those parameters into effect. And also, as much as a baseline is standard, but it doesn't mean it cannot be adjusted or it cannot be reviewed as you proceed in your efficiency journey. It's just that it will depend on the quality of data, but as far as possible, as long as it has met the above requirements. Thank you.
Thanks, Mbali. Okay, hopefully that covers that one. Meryl, do you want to have a crack at the
Yeah.
one about the links to the observatories?
Yeah, so I'm actually visiting Kucha on Monday, speaking to a lady called Micah Vetch about something totally different. So thanks for the tip. I'll actually bring this up with her as well, literally on Monday. So yeah, thank you. So around, how do we get, basically your question is kind of how do we actually get government to think in terms of data observatories for collecting data towards this kind of holy grail of a single source of truth. It's not from lack of trying. So we have spoken, originally we got a little bit of funding from the Department of Science and Innovation for our proof of concept that we've developed. Yeah, it's an issue, and we've presented to DTIC as well. There hasn't been that much interest. So we're obviously speaking to the wrong people. So, any advice you have there would be very, very welcome. I'll speak to you afterwards and I'll get your email address, etc. Thank you.
Okay, thanks for that. I'm just we're just checking as well if there's anything online that came through. But in the interim, I think there was a question on my right here. I'm not sure if I missed one on that side. No, okay. Can I offer you the opportunity? Yeah.
Thank you very much. I was feeling for Dinesh there, so I thought let me come up with a question. I hope it is Dinesh, right? Vinesh, okay. I felt sorry for you. I hope it's a welcome question. But I was actually in the CSIR in a room a couple of months ago, and they had put together a stakeholder engagement session that looked at quite a few mining companies and looking at the reporting requirements that they have, especially where they are exporting, because CBAM has come out quite a lot in the room today, but it isn't only CBAM. I think in terms of sustainability and other reporting requirements, there's a plethora of standards, and I don't think we're at a point globally or in South Africa where we can say that for a South African company, this is the standard, or these are the basic standards that you should be compliant to as a company in the mining sector, or a manufacturer, or someone in the foundry sector supplying raw materials. So in terms of the project that you worked on, can you share an example of how this data could perhaps start to plug into this plethora of reporting and global reporting and compliance standards that local companies are required to adhere to in order to remain in business? That was my question. Thank you, Vinesh.
Thank you very much for that question. So it's a very valid question, right? And everybody's struggling with this because once you have a first mover, there's no real standard to follow. And as we know, even with CBAM, the regulator is changing their mind continuously. So how this project can be an example of that is using a global template, which is what Microsoft Sustainability Manager is trying to create. But even they obviously have to keep optimizing it. But that could be a starting point. But then I think organizations like ISO need to get involved, right? And start putting together internationally accepted standards with the think tanks from all the other organizations, but that obviously will take a number of years once we have sufficient experience. So, but all the lessons that we have learned here can be transferred to others, so they don't need to pay the school fees. And I think, as your mining example quite rightly speaks, we can, that's why my colleagues in the mining part of the business are talking to them is how can we standardize it? That's what the data as a service that we are helping roll out in the mining industry. We'll start to standardize how mines look at their data. So it's then easier to, instead of everybody spending money time and time again reinventing the wheel, we have a template for everybody.
Thanks, Vinesh, for that. You're lucky because I also had questions that I was going to fire at you guys if we didn't get enough. So it's a good thing that I was preempted there. Ladies and gents, I think we've reached the end now. Unless there's anybody with an absolute burning question, I think we're now competing with lunch. Oh, there seem to be, yes. Okay, I'll allow that one and then we can look at wrapping.
Thank you. My question is directed, I think, to Hendrik, but I'm going to via through Davi and Bali. This one is based on the alternative energy that they got for their factory. I just want to understand based on the data information. I'm not sure if the plant is somewhere behind the municipality or in their space, and how do they see the reduction in cost of energy? And what's the visibility then? And how do they do these bilateral agreements between the generator, transmission, and to their factory, and seeing that data? Thank you.
Okay, who's brave enough for that?
I don't think Hendrik has got a plant producing solar. That is why he spoke about a power purchase agreement earlier. The power purchase agreement is what they set up to buy green power over the fence through, it's just a normal accounting practice where you say, I'm feeding this much energy into the grid through a wheeling agreement. You guys in Pietermaritzburg can pull out this much. So it's an accounting practice basically. So there's no plant per se, but in terms of managing and in terms of making sure that you're monitoring, you also need to know how much green power you're purchasing and feed it into a system. The system, Red Screen, has got offsite renewables section. You click on the offsite renewable section and you can feed that type of information in. Okay.
Can we leave it there? Yeah. Okay, so that was it and concludes it. But before I release you for lunch, I was asked to just make mention. You see the QR code up there. That's one you could utilize. Alternatively, they will be displayed in the foyer area as well when you go out for lunch. Please do play with them. One, I think, has got our carbon footprint on, so we're looking to calculate that for the conference and give feedback. And then the other one, I think, is also a feedback and comments survey as well. So we'd appreciate your participation. It's also a little bit of fun. You learn how to do something different. So with that, I would like to thank the presenters for their presentations and you as the audience, and enjoy lunch. Thanks.